Let's now look at example 13. Globally, the long-term proportion of newborns who are male is 51.46%. A researcher believes that the proportion of boys at birth changes under severe economic conditions. To test this belief, randomly selected birth records of 5,000 babies born during a period of economic recession were examined. It was found in the sample that 52.55% of the newborns were boys. Determine whether there is sufficient evidence at the 10% level of significance to support the researcher's belief. All right, so let's notice first of all that on a long-term basis, the proportion is 51.46%. So that's going to be our null, that the proportion is 0.5146. The researcher believes that it changes, so it could change in either direction. It could go down or go up, so we're going to have a not equal to 51.46% for our alternate hypothesis, and then a 10% level of significance, so alpha is 0.10. All right, so let's go ahead and put that in. Our null hypothesis is going to be that P is and let's go back here for this long decimal, 0.5146. And then our alternate, we said it changes, so it could change in either direction. So we'll have that P is not equal to that. Let me get my symbol for not equal. There we go. And for some reason it's being ornery. There we go. All right, and then alpha is 0.10 in this instance. All right, now this is a two-tailed test, so we want to divide alpha by 2. It's going to be 0.05. And now let's look up 0.05, and let's remember, since it's two-tailed, we'll have two critical values. So equal norm.s.inv 0.05, and we're expecting this to be negative 1.645, yeah? Well, it's just because it's the same as 90% confidence. All right, so we'll have that z is negative 1.645, and of course its opposite, positive 1.645. And these are our critical values. Now it's two-tailed, so let's remember our left tail. If we get a test statistic that's to the left of negative 1.645, we will reject the null. And if we get a test statistic to the right of 1.645, we will reject the null. So let's do our test statistic now. But before we can, let's get our p hat. Now in this instance, we don't have to compute it. It was given to us. Let's see. We have 5,000 babies were selected, and the sample proportion was 0.5255. All right, 0.5255. All right, so let's get our test statistic now. And recall, for our test statistic, we want to take our p hat and subtract our p-value that we, or rather, I don't want to say p-value, but our value for p that we got up here in our null. And then we want to divide by the square root of 0.5146 times 1 minus 0.5146 divided by our sample size, which was 5,000. All right, and let's go ahead now and do those two calculations. On the top, we get 0.0109, and on the bottom, we get 0.007068, and if we divide that out, we get 1.0 0.542 as our test statistic. Now, let's note 1.542 is not to the right of 1.645. It is, in fact, in between these two values, which means it's not in the rejection region. So we fail to reject the null. All right, so there is not enough evidence, alpha equal 0.10, to reject the null hypothesis. It appears that the proportion of males born during economically low periods does not differ from 0.5146. All right, now while we're here, let's go ahead and look at this as if we had done the p-value approach. Recall, if we do a p-value approach, we do not do the critical values. We instead take our test statistic, 1.542, and we look up what the p-value is. Now remember, since this is a two-tailed test and our test statistic was positive, we're going to look this up, subtract it from 1, and then double it. All right, so 1.542 equal norm.s.dist 1.542 true gives us this value, 0.9385. All right, so right here I'll do 1.9385. Do that subtraction, gives me 0.0615, and then because it's two-tailed, we need to take 0.0615, and we need to double it, and that's going to give us 0.123. So our p-value is 0.123. Let's notice that p-value is larger than alpha, which means we failed to reject the null hypothesis. So that result is still the same. We could say right here, though, there's not enough evidence. We can change this to a p-value of 0.123. Not enough evidence to reject the null hypothesis. Again, our result is the same whether we're using our original critical values or using the p-value approach.